peer-to-peer journals. Now, Dr. E. Murugavalli ma'am will guide us through the fascinating topic 6G communication with AR and VR technologies presents numerous opportunities for advancing patient care. Let us extend a warm welcome to Dr. E. Murugavalli ma'am to share her valuable insights with us. Over to you, ma'am.
Okay. Thank you, Dr. Menaga and Srija, for a nice introduction. So, actually, I have two sessions in atal FDP program, and this session I plan to cover the impact of 6G communication for transforming healthcare, especially using AR/VR technologies. Tomorrow, I'll plan some examples related to healthcare informations, healthcare technologies, especially by using AR and VR. And this session, I spend time on the impact of 6G. What are the features and what are the enabling technologies behind 6G, so that transformations happen in various fields today. So I go to next slide. So transformation happens not just in healthcare. 6G is actually enabling revolutions uh, in communication technology, not just communication technologies. It is going to have impact on transportation, smart cities, uh, real-time gaming applications, and healthcare as well. So the primary objective of 6G communication is to enhance connectivity. So the connectivity is capable of the capability of the connectivity is due to its various features. So it is enabling real-time data processing, and so the AR/VR applications will give you immersive experience to users. So along with 6G and AR/VR technologies, the healthcare will become more efficient and more accessible and personalized. So healthcare or patient care will be of global scale in future by combining these three together. Especially real-time remote surgeries would be happening through 6G technologies, and early detection of diseases and prediction of diseases and disease analysis. So those kind of things we can do with the help of AI powered techniques. Especially 6G is going to support AI so that we can do those kind of analysis. And especially augmented reality and virtual reality techniques will give some patient therapy and medicine based training. For example, medical applications will be easily simulated, and medical trainers will be trained easily with the help of uh, augmented reality and virtual reality techniques. So in the case of smart hospitals, we can combine IoT and automation to have secure telemedicine with the help of ultra-fast communication provided by 6G. So now, what is the role of 5G and 6G in enabling healthcare evolution? Usually, 5G is also having high data rate, and it is actually giving up to 1 gigabits per second, 10 gigabits per second of peak data rate, and it is giving 1 millisecond latency. So 5G is having some advanced features, but in spite of that, 6G is going to have great impact on healthcare because some enhanced features 6G is going to have, because 6G is going to have around 1 terabits per second data rate, peak data rate. So 100 times faster than 5G. That means real-time applications can be easier with the help of 6G. So we need immersive experience in the case of healthcare technologies, and we need real-time data processing for healthcare data diagnosis, and we need zero latency, absolute zero latency. There should not be any time delay for having remote surgery applications. So this is the reason 6G is emerging technology for healthcare evolution. So in the case of ultra fast and low latency telemedicine, 5G is capable of improving video consultations, but it is limited by bandwidth and latency. So you cannot have seamless connectivity due to the issues in bandwidth and latency. But in the case of 6G, it enables real-time, ultra-high definition virtual consultations with AI-driven diagnostics. And it is possible for doctors to monitor patients remotely with near zero delay, and so they can give you emergency response. And in the case of real-time remote surgeries, 5G enables assisted robotic surgeries, but some issues due to delays and some network limitations due to bandwidth inefficiency compared to 6G. But in the case of 6G, surgeons can perform robotic assisted surgeries in real time, remotely with real time haptic feedback, reducing the need for expert members to be on site. So, the global scale in healthcare technologies can be possible with the help of 6G. And this improving the access to quality healthcare in rural and underserved regions. And as already specified, AI-driven diagnostics and predictive healthcare is possible in 6G because there is a enabling technology in 6G, that is edge computing. This will enable instant data analysis of medical images, wearable data, and patient history locally. So usually in the case of 5G, the data storage will be there in cloud platform. So whenever there is a cloud-based services, you will be having enormous delay. Okay, so we cannot have real-time data processing and remote surgery kind of things will not be possible in the case of 5G. But in the case of 6G, there is near zero delay, and there is a edge computing uh, possibility so that we can do data analysis in real time. And so another advantage, early disease detection, which is mandatory for cancer and neurological disorders, etc. So in the case of medical training and education, 5G is giving you AR and VR based training, but it is having some delay and resolution issues due to its bandwidth limitations. But in the case of 6G, we have around 95 gigahertz to 1 terahertz bandwidth frequency range. We are having bandwidth efficiency, and so it supports immersive medical simulations with holographic models, so that hands-on learning can be enabled for medical students without any risk to real patients. And in the case of personalized and immersive patient care, VR therapy is possible for pain management and mental health in 5G. But in the case of 6G, we can have hyper-realistic VR therapy for treating anxiety and chronic pain. So the customer treatment plans be based on real-time biometric data from wearable devices. So the patients will have wearable devices and sensors will collect the data, and the treatment plans will be done at real time without no delay. Then IoT devices, usually IoT devices, smart devices will collect patient data, and these data will be stored in cloud and will be process the data at offline. But in the case of 6G technology, instant processing of health data at the edge computing is possible so that the delay can be enormously reduced. And the case of data management, improved security is there in 5G, but still vulnerable cyber attacks are possible in 5G because any strong cryptographic techniques can be broken. Okay, so if you have high computing machines available with you, a very strong cryptographic techniques can be broken. But in the case of 6G, there is something called quantum encryption, which is a emerging security mechanism, which is enabled by 6G communication, and AI-driven security will ensure patient data protection, especially patient privacy information is ensured in 6G. So health record can be preserved by using 6G technology. So 6G is being considered as a future of wireless technology because it is going to give you many features for the next generation humankind. And we know that there is a 10 years technology gap for every evolution. So we expect the deployment of 6G in 2030. It gives you, it will give you ultra high speed connectivity, near zero latency, AI driven automation, and advanced security. So this is possible to support immersive technologies like augmented reality, virtual reality, holography, artificial intelligence, and IoT at global scale. So along with these features, 6G is going to have distributed radio access network like open radio access network and terahertz spectrum to increase capacity and lower latency and improve spectrum sharing. So due to the wide frequency range, 6G technology can have multiple use cases for a variety of industrial sectors to enhance their efficiency. For example, 6G internet is going to give you a very lesser delay, less than 1 millisecond. That means the minimum delay is 1 microsecond. So the delay is 5 times reduced than that of 5G network, so that massive data transmission is possible within no second. So these are some applications of 6G in healthcare scenario: real-time remote surgeries, artificial intelligence based data analysis and diagnosis, AR/VR based medical training and assistance. And in the case of smart cities, autonomous traffic control and smart building sensor enabled control. And in the case of holographic communications, ultra realistic virtual interactions can be enabled. And we have a metaverse environment, that means combination of AR, VR, and merged reality, so that a user can experience the virtual world similar to that of real world. So these are all possible through the features of 6G. Then driverless cars, autonomous vehicles, unmanned aerial vehicle, and virtual vehicle to vehicle communication, vehicle to infrastructure communication. These are all become reality due to features of 6G. And again, in the case of space communication, it will give you enhanced satellite networks enabling deep space connectivity. And apart from those features, we have some challenges as well, especially deployment cost, infrastructure cost. Since 6G requires new terahertz spectrum, so we need to have enhanced base stations. We need to integrate advanced AI, And energy consumption we need to consider, since AI-driven power management is required to ensure efficiency, and ethical parameters again need to be considered. Quantum security and data privacy must be addressed. Usually, communication technology will be categorized based on the quality of service parameters. So usually quality of service parameters will be in terms of data rate the technology is giving you, the latency it is giving you, number of devices to be connected, and what is the loss in communication, maximum acceptable loss for that particular application, maximum bits that can be transmitted per second, and the variable time delay it can accept can be allowed. So those kind of parameters will be specified for different applications. Along with those quality of service parameters, 6G communication is giving you quality of experience parameters, because tactile feedback and haptic technology will have sensory experience. Okay, so the realism of sensory experience is possible through quality of experience. The quality of user experience parameters are specified for 6G. For example, latency is crucial for real-time applications, especially multiplayer real-time gaming applications and telepresence surgery. In this, latency is not acceptable and it should be very, very less. Then another quality of experience parameter is packet loss rate. Usually packet loss is acceptable for some kind of applications. For example, if your application is having redundant information, and some packet loss is acceptable, but when video quality is not compromised, for example, AR VR based applications in which user is going to experience like real world scenario. A virtual scenario will look like a real world scenario in virtual reality world. So quality should not be compromised. So video quality should be improved. So packet loss rate should be very, very minimum. That will be enabled only by 6G. So the overall smoothness of experience can be enabled with the help of 6G techniques. Then bit rate, the rate at which bits are transmitted. So it will determine the resolution and quality of video streams, particularly important for high definition content. Then another quality of experience parameter is jitter. Jitter means variable time delay. So time delay will not be constant for all the duration of communication. Sometimes variations in time delay is there due to the loading of network traffic. So in spite of the variations in network traffic and variations in time delay, we should have a real-time applications, real-time video conferencing applications, etc. So the jitter is very, very less in the case of 6G. Then perceived visual quality. This is a subjective assessment of video quality based on factors like sharpness, color accuracy, and motion smoothness. And of course, AR VR applications will give you immersive experience. So the degree of user immersion and feeling of being present in a virtual important is essential. And again, in applications like haptic feedback, involving haptic feedback, and in which the sensory informations are actually important along with other information. So the precision and realism of sensory experience is important. That is again another one quality of experience parameter. So these are the enabling technologies for 6G. So we have terahertz communication, we have optical wireless scenario, massive MIMO and intelligent reflective surfaces, self-free communications, artificial intelligence, unmanned aerial vehicle, mobile edge computing, blockchain, and quantum communication. So, terahertz communication is meant for improving your bandwidth and data rate, especially optical wireless. Massive MIMO is used for improving your reliability. Okay, so reliability is again important parametric in communication technology. So we all know that MIMO is giving you more reliability based on more number of antennas, a transmitter and receiver. The fading is exploited. Diversity is exploited, and so fading can be overcome and reliability could be improved. Now, 6G is extending 6G communication is technology is actually having one more technology called IRS. IRS is referred to as intelligent reflective surface, where the coverage can be enhanced, signal strength can be increased by having intelligent reflective surfaces. And then cell-free communications, in which distributed access points or base stations are collaborated together so that users can have a seamless connectivity while they are moving from one region to next region. And mobile edge computing is another peculiar enabling technologies, because real-time data processing is possible through mobile edge computing. And blockchain technology is distributed data management. Uh, when the data is to be secured, we need to go for some peer-to-peer kind of networking technologies. Blockchain is going to support it. So data privacy and data security is enhanced in through blockchain networks. And of course, quantum communication is going to give you security for future applications. Okay, so this is your IRS environment or reconfigurable intelligence surface. Now, in the case of 6G bandwidth, it's about millimeter wave frequencies and terahertz communication. All high frequency band will be affected by some attenuation issues, path loss problems, and especially blockage. So if there is any obstacle between user equipment and base station, like large building or trees, your signal gets affected. So we should have some relay kind of things whenever there is a blockage. So now this relay is reflecting surface. Okay, so there is a surface in which huge number of or array of radiating elements will be located, and those radiating elements will receive the data and reflect the information so that the devices beyond the blockage can be connected. So this is a upcoming technology used in 6G. So I skip this. So these are the use cases of 6G. Actually, 5G is having extended mobile broadband, ultra reliable low latency communication, massive machine type communication. Along with these use cases, 6G is going to give you artificial intelligence, power data management, sensing, etc. So that we can have applications like video streaming, multimedia applications, massive data download and upload through extended mobile broadband technique. Then in the case of ultra reliable low latency communication, mission critical applications can be possible. So in the case of autonomous vehicles, the delay is very, very less. So the delay should be very, very less. That is enabled by ultra reliable low latency communication. And in the case of massive machine type communication, IoT, wide range IoT services would be enabled, especially in the case of smart city, smart building, and smart healthcare applications. So, billion and million to billion devices would be integrated through extended massive machine type communication. So, um, data rate, bandwidth are extended, reliability is enhanced, and delay is reduced. So these are the extended version of 5G use cases. But in the case of 6G, AI autonomous network management is newly added to it, and intelligent edge computing is possible only in 6G. And high accuracy localization and tracking. This is another important feature. And augmented human sense and industrial IoT is possible. And this is again newly added. So enhanced mobile broadband will give you gigabit level speed, ultra low latency, high reliability to support advanced applications such as virtual reality and augmented reality, autonomous vehicles, and advanced gaming. In the case of machine type communication, we can have IoT connectivity. Massive machines can be connected. Billions of devices can be integrated together. So uh, it will provide, and again another advantage is low power consumption, low data rate transmission. So most of the mission critical applications are done by smart devices, and they are all battery operated. So it should include energy efficient technologies to conserve power. And again, it is going to give you some control informations, which is of very low data rate information. And ultra reliable low latency communication is the use case that focus on ensuring low latency and high reliability for real time communication. And this is especially for mission critical applications such as autonomous vehicles and industrial automation. And again, artificial intelligence, 6G is expected to bring artificial intelligence to the network's edge so that real-time data processing and decision making will be possible. This will provide the foundation for advanced applications such as autonomous vehicles and smart cities. And it is expected to support advanced sensing capabilities, including enhanced location accuracy, 3D imaging, high resolution sensing, which will be crucial for smart cities, precision agriculture, and industrial automation applications. Then, in this case of security, and again in the case of massive IoT, massive machine type communication, with the increasing number of connected devices and transmitting sensitive data, security will be a crucial consideration for 6G. Advanced security mechanisms such as secure device identity, secure data storage, secure data transmission will be essential to ensure privacy and security of users and their data. In the case of data communication, uh, data communication for mobile technology, the security is different. But in the case of data communication in IoT environment, um, different kind of security mechanisms should be there, because uh, in many um, in many scenarios, data apart from data, you need to identify the location of the data in which location of the data, because the location information is very much essential. So we need to identify the location, we need to identify the device from which the data is generated, So in that scenario, we need to secure the device identity as well. So this is important for IoT kind of scenarios. So this advanced features, advanced security features are again are possible in 6G. So now I have a video and demo for AR-based application in which fine motor therapy application is considered using avatar-based artificial intelligence for autism children. This has been developed by Dr. D. Tamilselvi, Professor of IT Department, TC Madurai. So is it visible to you?
Yes, Murugavalli.
So we know that autism children need to be properly trained because they won't understand some kind of activities, especially some fine motor activities are essential. At fine motor activity training should be essential for autism affected children. So Um, this particular project is meant for enhancing the trainers. Actually, trainers, there are some trainers. They will be giving training to the autism affected children. Now it is very very tedious for those trainers to train the fine motor skills for the children. So now the technology is going to assist that particular training process. How this is done? This is done by using a virtual environment. So initially, a virtual environment is created, and this with the help of avatars, that is a digital representation of a humankind, and the children will be given with VR devices like goggles and other things, and then this kind of virtual environment will be exposed to the children with goggles, etc. So they will be trained by using this kind of environment, and so they will be properly trained and they will be easily trained. So this is the objective of this thing. So this is actually a virtual environment to create a play area. So the children will be exposed to this kind of virtual environment. And this particular activity is meant for choosing correct object to find the placeholder, correct placeholder. One second. So this is another kind of activity to practice. So this activity is for distinguishing color information. And a lot more activities can also be created virtually by using uh, the VR tools and VR gadgets. So in the case of virtual reality, the virtual environment is created by using 3D modeling, Blender, and Unity software. And in the case of augmented reality, the real world will be enhanced by using digital element. Here, no use of gadgets or VR devices needed, but only the enhancement of real world is possible, is enabled in augmented reality applications. Most of the cases, this will be computer generated digital information, which will guide the real world. So the real world experience would be enhanced by using AR. So this will include a visual, sound, and other sensory elements. And it will use computer hardware and software such as apps, consoles, screens, or projections to combine digital information with a real world environment. In the case of healthcare sector, AR will benefit the healthcare sector in a bigger role. So there are AR apps that will enable the users to see highly detailed 3D images of different body systems when they hover mobile devices over a target image. So this will be a powerful learning tool for training medical professionals. Now, many medical institutions are using this AR-based applications to train the students or medical practitioners by using by combining the digital elements to the real world environment. So in this case, the AR apps will enable users to see highly detailed 3D images of different body systems when they hover mobile devices over the particular target. So they can have enhanced experience of the particular real world environment. In the case of virtual reality, it is used to describe a three-dimensional computer-generated environment. This is a virtual environment that can be explored and interacted with. So for having interaction, we need to have special goggles like VR headset, and they are placed over the eyes and fully immerse you in a virtual environment. This will create a realistic experience in the simulation. So the environment can be interacted with using either hand controllers, gloves with sensors, or the VR header itself. So you can have a real world experience by using a virtual environment. So this kind of virtual environment, which have been created in many of the entertainment industries, especially watching 360-degree movies, where entire environment surrounds you as you watch. And this is again used in gaming applications, especially multiplayer gaming applications. We use this kind of techniques. So in the case of healthcare applications, we need to have enhanced connectivity for remote care. So especially the latency, which is it should be very less than 1 millisecond, and even up to 1 microsecond latency is possible through the deployment of 6G. And data rate, the peak data rate is up to 1 terabits per second. So this will allow real-time applications like telesurgery and holographic communication, so that the remote diagnostics and treatments are possible through the enhanced connectivity. And in the case of visualization and immersive experience, both augmented reality and virtual reality will enhance telemedicine, training simulations, and diagnostics by providing high quality and immersive experiences for healthcare professionals and patients. And along with the connectivity of massive medical devices, Internet of Mobile Things integration is possible. So 6G ensures pervasive connectivity and real-time communication for IoT devices, enabling better patient monitoring, faster response in emergencies, and improved overall healthcare system efficiency. So there are many challenges in integration of these technologies together. So first one, infrastructure deployment issues. Implementing 6G networks and AR/VR systems together requires significant investment in advanced infrastructure, including communication towers, satellites, edge computing facilities, high performance servers, specialized hardware requirement, and extensive connectivity upgrades to ensure seamless functionality and integration. And again, cutting edge AR/VR technologies demanding extensive R&D funding. Then advanced devices such as headsets, haptic sensors, 6G enabled devices involve costly manufacturing process. So maintaining the massive infrastructures for installing 6G towers, the energy requirement is enormous. The operational expenses are again high. So due to the integration, the privacy and security is another challenging one. Um, and so AI will integrate, will be the integral of 6G, enhancing infrastructure and computing layers while introducing new security challenges. Molecular communication, a low energy nanoscale technique for 6G. This will show a promise but faces security and privacy challenges, including vulnerability to attacks. So that quantum communications needs to be incorporated to enhance security. But there are many challenges the 6G will going be facing in long distance transmission and requires advanced encryption methods. And again, ethical issues are other, and again, are big challenges in implementing these kind of things. So the commercialization of AR/VR technologies while driving innovation can create unequal access due to high cost, highlighting the need for the inclusivity and affordability to ensure broader access, especially in fields like healthcare. So these kind of ethical issues again need to be taken care of. Challenges in infrastructure, regulatory bodies will support sustainable technique, and while 6G may rise carbon concerns, its energy efficient applications can reduce emissions. Actually, 5G is also having the same kind of issue. Energy efficient applications need to be taken care. Uh, and then network compute fabric. 6G must deliver flexible architectures to meet diverse use case demands, optimize edge deployments, and ensure superior quality of experience in latency and bandwidth. And coverage. Uh, so the extended coverage is possible in 6G, and this will create an integrated digital world, but this brings challenges including economic concerns. So there are challenges, and the more and more challenges are there in non-technical and technical as well. Actually, I have around 20 more slides. So I think this can be covered in the next session. And should I continue or shall I close it now?
If you want means we can continue or else we can continue tomorrow also.
Okay. So I think I can continue further slides tomorrow in tomorrow's session.
Okay, okay.
So if any specific questions, I shall
So,
address.
participant, you have any question regarding the AR, VR? You can any question is there? Participant, any question is there? So, Murugavalli, appreciate your preparation with the. Can you hear me? Hello?